Okay, everyone, here's number 13. So, in the last video, we talked about a little bit about domain and range. Here's another thing that's unique to advanced mathematics is you're going to actually be analyzing graphs of the functions more, not just graphing them, but analyzing them. And another thing they'll ask is, when is it increasing or when is it decreasing? So, let's get right to it. So, if basically you just start at the left end of the graph, it starts right there at -2, -2, and from there, if you just follow the graph, see how it's going up. Well, that's increasing. Notice right here at 2, it now goes straight across. Y equals 2, it goes straight across. Obviously, it's not increasing if the slope is 0, right? And then notice the graph from 1, 2 is going down. And then finally at 3, 1, the graph is bending back up again. So what I have in red, guys, is where it's increasing. Yellow is where it's neither increasing or decreasing. It's basically leveled off. And then blue, of course, is where we would say it's decreasing in height or value. So here we go. So x was -2 here. It leveled off at -1. So we know from that interval there, from -2 to -1, right? It's increasing. At the other end, starting at 3, and basically, theoretically, it goes on forever. As we would say to infinity, it's increasing again. So if you look at your choices, you'll notice here's a choice. Now, another thing to note, guys, is this is not an ordered pair right there. One way in math we show intervals is we'll use parentheses. So like -2, -1, as you see right there, really means is that x is between -2 and -1. Okay? And so we use parentheses and brackets now to show intervals, and that's something you have to get used to. So anyways, the choice was C there. All right, this one right here. Notice, starting right here at x equals 0, 0 looks like 0, 1. It's increasing all the way to this point right here, which looks like it's around 5, 6. I'd say the coordinates is 5, 6. Now, after this point at 5, 6, that's what we would call a relative maximum value, by the way. It's now decreasing all the way down, right? And so what I've shown in red initially here to here is where it's increasing. So it's increasing from 0 to around 5. And so that's why I would pick choice C. Okay. On this one, notice they're asking for decreasing. Well, let's just talk about both. Obviously, starting here, it's increasing. And then again, at that point, 5, 6, it bends back down and it's decreasing, right? It's going down. So to explain this, we would say the intervals from around 5 all the way, it seems to end around 12. So we know that's not 0.512 again. That means the interval from 5 to 12, or when x is between 5 and 12, it's decreasing. So that's why the choice is C. Okay, these we're just solving absolute values. So hopefully you remember that with the absolute value, guys, you have two answers. We know x minus 2 equals positive 5, but we also know x minus 2 equals negative 5. And solving this simply, all I have to do is add 2 to both sides. X equals 7, or x equals -5 plus 2 is -3. And as you can see, now those are braces, guys, so it's not an interval. With braces, it's like a set notation. So we want -3 and 7, and that's what choice B is. Looking at this next problem, 51, the trick to this one, guys, follow the red. I'm going to -4 both sides. So I end up with this, absolute value of 6x minus 7 equal to -3. Now, before I proceed any further, this one is designed to trick you guys. Please remember, think about this. Can the absolute value ever end up being a negative value like -3? If I, for example, took the absolute value of 5, isn't that positive 5? If I took the absolute value of -11, isn't that still positive 11? So absolute values always yield positive values at the end, correct? So that's why all of these choices are there to trick you. Okay? If you have a negative, guys, an absolute value in the end can never be a negative. That's why the correct choice is D. So please remember, absolute value can never be a negative value. Okay, I think I put in one more here. This one's quick and short to the point, guys. Do you agree? They're asking for the degree. That's basically the highest power, basically, of our polynomial. So you ready for this? Do you agree I have a square here, and with that x in front, I'm going to end up with some form of x squared plus or minus something, am I not? In my next parentheses here, I have a 3 power. So that 3 power is going to give me an x cubed, and plus or minus some other forms of polynomial powers, correct? Long story short, the highest power here is x2. The highest power here will be x3. Timesing by a constant 2 in front is not going to change the power or exponent. And if we times these together, would we not get x to the 5 plus or minus some sort? So that's why the degree is 5. The highest power possible in this expression is 5. So therefore, the degree is 5. So guys, if you have any questions on any of these, please let me know. Please speak up in class. Whenever we have a little free time in the middle or in the class, just say, Mr. Ormsby, in IM 3, you did this problem in the video. I still don't get it. Could you explain it? And you know I'll be there to help you guys, okay? So anyways, keep up the good work. See you in class.